Okay. All right, so we have some homework and we will be dealing with functions and composite functions. You learn what they are. Okay, let's look at the homework. Okay, Latoya, did you do your homework?
No, I told you I don't have time. Remember, I told you I have another class on Tuesdays and Thursdays. You didn't read my text the other day?
You sent me a text that you had
Yeah, I told you I
classes.
was doing the college prep. You forgot?
I I didn't know
You
you
didn't
sent
understand the text. That's why, maybe.
maybe when did you send me that text, Latoya?
Um, last week
That's
I told you I was doing the college prep class.
oh, I know
I
you
sent it
said
to you,
you
but you
told
never
me that.
answer. You never answer, so I guess you didn't understand what I was saying.
Maybe I didn't get it. Let's see. Let me
Yeah, I
check.
said, I started the college prep class Tuesday and Thursday, the reading comprehension and the essay writing.
Okay, let's see. Where is
It was
your
when we do the math so fast, and I was like, you have to speed up because I'm preparing for college. That was the text I
oh
sent
yeah,
you.
that's
Yeah,
okay.
so
You
that's why I was doing a lot of things because I'm doing the college writing essay how they want it in college.
okay.
You understand? So it's a lot of work. I'm between church, work, school,
Hey,
everything
I'm
mixing up.
preparing for college. That's why I'm learning to do things faster. But I didn't see where you said you were going for college prep. I don't have that message.
I guess you must have didn't read this stuff.
No, I didn't get that message, Latoya. I'm looking back through because I haven't deleted your messages, so I didn't get it. All right,
Oh,
let's look at Audrey. Did you get this that you see on the screen? Functions review and practice. Did you get that? Audrey, where are you? I lost her.
she mute.
She's not even showing. Audrey,
Cut off.
I should have to log back on because I don't even see her.
When
Yes.
she log off.
Audrey, text her and tell her to log on again.
When the Zoom started out, it was good, but now it have a lot of mishaps.
Yeah, that's true.
Now, yeah. Even I'm doing Adam off it, submit my homework, and we submit some and left some.
Tell her to log in again. Okay. So let's look at this first question, Latoya. Linear function. And this is our old familiar what? What does this look like to you, Latoya?
MX plus B.
That's it. Very good. That's our old slope intercept y equal mx plus b. All right, something we are familiar with. So the function is s of x, which could be y, 0.4x plus 2. And 0.4 is the slope. So that represents the, the change of, all right? And the 2 is our constant. So S of X is our total cost, and that's our dependent variable. And the dependent variable is dependent upon what? The weight of the envelope. Because the 0.4 said you're paying 0.4 an amount per ounce. X represents the number of ounces plus the $2 charge that's a constant. Now, based on what you just saw here, Latoya, which one would be correct? A, B, C, or D?
That's a C.
The cost of shipping the envelope is $2 plus 40 cents per ounce, and that is correct.
Yeah,
Okay.
that's the first thing pop out.
Yes, very good. Answer C, because answer C has what? $2. That's your
Yeah.
fixed cost that we call our y-intercept on our y equal mx plus b slope intercept formula. And the 0.4 is like 40 cents. That's 0.4 of a dollar, which is 40 cents. And X represents the weight of the envelope in ounces. So the total cost, the total shipping cost for the envelope is 0.4, 40 cents per ounce plus $2, which is the fixed cost. Or it could be a service charge. You will pay that regardless of the weight of your envelope.
Yeah.
See, Audrey is trying to connect again. Audrey, you're on mute.
The screen, right.
Audrey,
Yes, you can hear me now?
where's the noise coming from?
Because I think she can hear you now.
I can hear you, but where's the noise? Okay.
Probably me, Barbara. Let me come off.
Okay. Well, you were on mute, so it couldn't have been you.
No, I was talking to her on her phone.
Oh, okay. All right. All right, Audrey,
Yeah,
can you see this, the screen here?
yes.
Try these linear function problems. And this S of X, that's the function,
Mhm.
where S of X represents the total cost. That's like saying Y equal, like Latoya said, that's from our slope intercept formula, Y equal mx plus b, where Y is the S of X and the M is the 0.4, and then X, and then 2 is the B or y-intercept. So total cost equals 0.4, that's 40 cents, times the weight of the envelope plus a $2 charge that you pay regardless of the weight of the envelope. Okay, now, so Latoya said C was the answer. That's absolutely correct, because the cost is $2, that's the 2, 40 cents per ounce, that's the 0.4x. 0.4 is 40 cents, X is the weight of the envelope. So that's why C is correct. Can't be A, because it's not just the 40 cents per ounce, but it's $2 in addition to that. So it can't be A. Can't
You
be.
said that X is what?
The X is the weight of the envelope in ounces. See, X is the weight of the envelope in ounces.
So what
S-
the SX stands for?
What?
The SX at the beginning.
Oh, this is the function. S of X is really the same as T. We could have said T equal, we could have said Y equal, but instead we say the function S of X, where X represents the weight of the envelope. So if I ask you, let's just go a step further. Suppose I ask you, how would you solve this? What is the cost of shipping an envelope that weighs 8 ounces? How would you solve that, Audrey? How would you solve that? What is the cost of shipping an envelope that weighs 8 ounces? Here's the function right here. The cost is the S of X. All right. So let's just put that here. The cost is the S of X. That's what we're looking for. The
It's
weight of the
0.4.
envelope is what, Audrey?
0.4.
No, the weight of the envelope. That's the 8 ounces.
8 ounces.
0.4 is the cost per ounce. X represents the number of ounces. This envelope weighs 8 ounces. So in this formula, in this function, we would put it's 0.4 per ounce, right? And it's 8 ounces. So that would be times 8. This is a decimal. And we add to that constant cost that you pay, and we add to that 2, right?
Mhm.
That's how you find the total. Now, S of X, this, when we put S of X, this would be, we change this X to say 8, because we're looking for the cost to ship an envelope that weighs 8 ounces. So S of 8 ounces is 0.4 times X, where X is 8 ounces, plus 2. So what would that be equal to, Audrey? What's 0.4 times 8? Audrey? 0.4 times 8 is what?
3.2.
That's it. Very good. 3.2. And then we add our 2 to it. And we get actually what?
3.4.
No, the 2 is the whole number. So the 2 is added to the 3. So that's going to be 5.2 or $5.20. So we put it in dollars. That's $5.20. So you get it?
I think so.
Yeah. See, when we say a function, see this function S of X, this is the output. That's the dependent variable. The total is dependent upon the weight of the envelope. The weight of the envelope is the independent variable. Okay, so this S of X could have been written T equals, could have been written Y equal. It's just that for a function, we say a variable and say what that input value is. So in our case, for 8 ounces, we put S of 8.4 times 8 and then do our calculation. Got it?
I'm so sure.
Okay, well, try another one. So suppose now, okay, we said 8 ounces. Suppose it weighed 1 ounce. What would be the cost? The envelope weighed 1 ounce. What would be the cost?
$4.20.
Be what?
$4.
No. The envelope weighs 1 ounce. Envelope weighs 1 ounce. Okay. What is the shipping cost? What is the shipping cost on an envelope that weighs 1 ounce? What would it be, Audrey?
Okay, let's see.
Same formula. Function equals. Let's just copy. Total. S of
I
X.
can't see what you're doing, you know.
You can't see envelope weighs 1 ounce. I'm on the other screen. I went to
Oh,
this.
you're on the other side. Oh, I didn't see
Okay,
that.
you see it?
Mhm.
S of X. See, S of X, we were told that was what? S of X is the total cost for shipping the envelope, right? But that total cost is made up of 40 cents an ounce plus a $2, say, service charge. So if I was shipping an envelope that weighs 1 ounce, what would be my cost? What would be the cost, Audrey?
42 cents.
No. It's got to be more than $2 because it's $2 regardless of the weight, right? So my X now would be a 1. And my X here would be a 1. Just substituting in for the variable. So what's 2 plus 40 cents?
42 cents.
What? $2 plus 40 cents.
It's $2.40.
That's right. That's right. Very good. Be $2.40. I'm adding $2 and then I'm adding the 40 cents because it's 40 cents times 1 ounce. That would be $2.40. Is it making sense, Audrey?
I still ain't understand it.
What part you don't understand right here?
This SX thing that you said, tell me and shifting it to this. I don't understand that.
No, see, functions represent, say, equalities actually. And we've been using like Y equals and A equal, B equal. Now we're using functions where the function variable has whatever you're substituting in for the independent variable, which is here is the weight of the envelope. All right. So instead of saying, I could have just said Y equal 0.4 X plus 2. That would be the same thing. But then it's a linear equation and it's not a function. So what we are doing, we are replacing this Y by a function that is a variable of a independent variable of an independent. So the variable here is S. The independent variable is the weight, which is in this case 1. Okay, so Y equal, instead of saying function of 1, I said Y, and then I'll substitute for my X 1 ounce, and I still get 240. And it's said, and the way we say that, we say S of X. That's the way we say the function, S of X. Okay, S of X. If this had been, say, V and X, we'd say V of X. All right. But it is our output, and what we have on the right is our input. So our output, say in the case of the S of X, is our S of X, and our input is the weight of the envelope, or X. Now, you could be given a total and asked to calculate what will be the weight of the envelope if it costs this much to mail it, right? For instance, suppose we had the cost for shipping an envelope is, let's see, $3.60. Okay. What is the weight of the envelope? Okay. If it costs you $3.60, ship it. That's the total cost, right? What was the weight of this envelope? How would you find that, Audrey? Audrey? How would you find it? Latoya, you know?
I don't understand this. Okay, getting it?
You're gonna, anyway, you see, you're gonna put
Hang on, I ain't
three
getting it.
sixty where V is, where X
Well,
is.
no, I'm back to my original. This is the function. Wait, let me just put it here. This is the function. Same function we had from the beginning.
Oh,
And
it's
my
same
cost,
function.
my cost for shipping the envelope is $3.60, which means I know my total. I just don't know the weight of the envelope. My question, how do I find the weight of the envelope?
So it's gonna be 0.4, and 360 in the bracket plus 2.
What?
S of X equals 0.4 with parentheses 360 plus 2.
No, 360 is a cost. Which one of these represents my total cost? S of X or X? Which one?
S of X.
S of X, because I said this was the total, right? See over
Yeah.
here, S of X is the total cost in dollars to ship an envelope. So that means for S of X, I put $3.60, right?
Mhm.
And that's equal to 0.4x plus 2. Now, Audrey, how do I solve for X?
Subtract 2 from both sides.
That's right. Very good. So subtract 2 from both sides. Okay, so let's just do that. Let's take this equation. Subtract our 2 from both sides. So minus 2. I just put 0 since we have the 60 cent. And over here, minus 2. Okay, so 360 minus 2 is how much?
It's
Audrey.
358.
360 minus $2.
Uh-huh. Oh,
160.
no,
What is it, Audrey?
minus
That's
$1, you say?
Hi.
One person at a time. Audrey, what's 360 minus $2?
That's 160.
That's it, 160.
Good
Okay.
afternoon, everyone. I'm sorry.
Hello there. Chastity, what's the right side? What do I get on the right side?
Mm,
0.4x plus 2
2.4.
minus 2. What does that equal to?
Mhm. I'm not sure about that one. I said the first one.
What's plus 2 and a minus 2?
Plus 2 and a
Minus 2 is
plus 2 and a minus 2 is, hold on.
I'm going to tell you plus and minus are the same number, or a variable number combination is 0.
0.
Plus 2 and a minus 2 is 0. So this is then what? 0.4x plus 0.
Plus 0.
So we have then $1.60
$1.60.
equal
0.
0.4x. So 0.4x plus 0 is x. Now, What number multiplies by 0.4 to give $1.60?
Let's just take her off the table.
4. Oh,
Hey, boss, we want to sit here.
What is it?
40.
Hey, loser.
40?
Multiply or multiply.
Well, you're dividing 1.60 by 0.4 or 16 divided by 4.
You really?
I mean,
Right.
you could get rid of
40.
that decimal, and that's 16.
Oh my God.
That's the same as saying 16
Wow.
equal 4x. Only one number multiplies by 4 to give 16. What is it, Chastity?
These little babies like unicorns.
It's
How?
4.
4. That's
4.
right. 4, that's right. X
Mm.
equal 16 divided by 4, and that's equal to 4. That means the envelope weighs what? 4 ounces. So 4 ounces
You're taking forever.
is the weight of the envelope.
Whatever. If you want to sit with
So-
this loser, go ahead.
So you can solve for the weight of the envelope if you know the total, or you can solve for what? The total if you know the weight of the envelope. Any questions on this? Audrey, is it making sense?
A little.
Okay. Because you've been doing functions before, except we weren't calling them functions. We just called them algebraic equations. Okay, but now we're calling them functions, and we found out that what?
Surprise.
If you have ordered pairs, you cannot have duplicate x values, right? You cannot have duplicate x. If you do, then it's not a function, because it's got to be a one-to-one relationship. No one x with two different y's, just one x to one y. Any questions so far? Okay, let me give you another one here. Let's stay with this. We're still working with this same function. S of x is 0.4 plus 2. Same function. All right. I'll put it here. I'm on the other screen. Okay. Okay. An envelope weighs 10 ounces, right? What is the shipping cost?
What is this? We're doing the number what? What is this?
No, we're still on number 1. I just gave you another example. It's still the function S of x is 0.4x plus 2. Okay, what is the shipping cost? And the shipping cost, total shipping cost, is the S of x. I said S of x is the shipping cost. The envelope weighs 10 ounces. All right.
Okay.
This is actually mental math, right? Because where you have x, you're gonna put 10 as your number of ounces, right? Anybody have the answer? So S of x, where x is 10. So you put 10. Now put 10 for the x here. That's what, 10.
Oh, excited. Where though?
So what's your answer, Audrey?
4.
What's your answer?
My daughter.
I finish it.
4/10 of 10. Mental math.
40.
It's like this.
40 plus 2, 42.
4/10 of 10,
40.
No. Then,
4/10 of 10,
a second. Yes. It's 4.
what's 4/10 of 10?
It's 4.
It's 4. And then add the 2.
It's 6.
So that's your answer.
Oh,
That's it. 4/10 of 10 is 4/10 of 10 is 4. Latoya, how you get 40?
Because I multiply it.
No, you didn't multiply.
I
Because
multiply 0.4 times 10.
not 4/10. Okay. So 6, that would be the shipping cost. So we put it in
So you just
dollars.
drop the 0.
Just one?
That's what you did. You dropped the 0.
No. 4/10 of 10.
so
What's
just
half of 10, Latoya?
it's
5.
5.
Right?
5.
So that's just 5. So 4/10 of 10 is 4,
Oh.
right? I didn't drop anything.
Mm.
1/10 of 10 is what, Latoya?
1.
1, right? 4/10 of 10 is 4, and then add the 2, and you get $6 is your shipping cost. Audrey, you okay with that?
Yes.
So you can find your shipping costs for any weight of your envelope. You just put that weight in your S of X, you're doing S of 10, and then you put the same number for your X here. And that's 10. Multiply it out, add it to your 2, your service charge costs, and that gives you $6 for the shipping costs.
So, Ms. Barbara, what's the difference between this one and the one at the top? What is the cost of the shipping?
Well,
An envelope weigh 8 ounces. What's the difference?
the difference is this is 8 and this is 10.
Now,
And
how do you know? How do you know when it's f of x?
well,
How do I put
you
it
know,
now?
well, okay. You know when it's a function when they give it to you as a function, like here,
Mhm.
right? They said uses the function S of X equals 0.4x plus 2. And they tell you what S of X is, the total cost in dollars to ship an envelope. But it's X, the weight of the envelope in ounces. That means if you know the weight of the envelope, you can find the total cost. You got it?
Yeah.
See, that's given in the problem. They gave you the function. That's S of X. That's the dependent variable. This is dependent
Oh, sure.
upon X, the weight of the envelope. Shipping cost is dependent upon X, the weight of the envelope, because the $2 is a fixed service charge.
Oh, shucks.
And there's a similar problem to that also in the real world. When you get in a taxi, generally, as well, I know with the yellow cabs, you pay what? A certain upfront cost plus so much per mile, right? So let's just say a taxi charges a fixed, let's say a fixed cost
Rate cost.
of $3. And a cost per mile of $2. All right. And I want you to set up the function, okay? What is the cost of a trip that is 6 miles. Estimate the math.
Happy to know, Mom.
What's the cost of a trip that is 6 miles? Now, you can set up the, we'll say, the total cost of the trip. And that's going to be what?
$3.
No, the total cost, we'll say X is equal to, and it's $2 per mile. So that's $2. And I'll put M here for miles. You could use X, but I'll say M is the miles. So the total miles will be equal to what? What would the total miles be equal to? $2
$2 per mile
times the number of miles plus what?
plus $300.
Plus the
$2.
plus the $3. That's right. So that's your function. The total cost is equal to $2, because that's how much per mile, 2 times M, plus the $3 fixed cost. All right. So if you travel 6 miles, then when you rewrite this function, you'll say T of 6 equal 2, and your number of miles is 6, right? Plus 3. And what's that equal to? What's 2 times 6, Audrey?
It's 12 and 3 is 15.
That's right. 12 plus 3 equal 15. So that means the cost of a trip that is 6 miles will cost you $15. So that would be the cost. All right.
Mm.
So that's a function where you have a fixed cost and a variable cost that varies by the number of miles you travel. The more miles you travel, the more you'll pay for the trip, because the trip has a fixed cost plus a $2 per mile cost. Okay, so that $2 has to be multiplied by the number of miles, added to your fixed cost of 3, and for a trip that is 6 miles, you pay $15. Audrey, is it making sense?
Yes.
Okay, so that's another real world function. Another one is if you have a plumber, normally you pay a plumber a certain amount, say if he comes to give you an estimate, right? And sometimes the estimate is applied to the bill, sometimes not. But sometimes they will tell you, I charge a service fee of a certain amount and then so much per hour that I work. So that there again, you have 2 charges. You have a fixed cost, the service fee, and then you have a variable cost, which is dependent upon the number of hours they work. So these functions have relevance in the real world, okay, where you have a fixed cost and a variable cost. The variable amount being actually the slope, the change in the units. And here again, if you knew the cost of a trip, you could figure how many miles, right? If you knew the trip cost a certain amount, you could figure what? How many miles you traveled. Let me give you an example here. And you tell me how many miles you traveled. A trip cost, let's see, 27. Okay, a trip costs $27. Okay, how many miles was this trip? Okay, you solved that one. Use the same function. It's that same function, except I'm giving you the cost. And the cost is the sum of the $3 plus the $2 per mile. Are you putting in your numbers to solve it?
Time. The time. It's $2, you said?
Yeah, the cost per mile is $2. That's the 2 that's right here, Audrey. 2 times the number of miles plus the $3 fixed cost. And I'm giving you the total cost of the trip, which means I'm giving you this T of M, because that's the total. Substitute that in and find M. Anybody got it? Any answers, Latoya?
$57?
No, the trip costs 27. How many miles was this trip that cost 27? T of M is the total cost.
T of M would be 27 then, where the M should be?
T of M is 27. That's right, Audrey.
Okay. And that is equals to,
Yeah, so you're right. This will be 27. And what is that equal to? Just what we have on the right, right?
2 plus
2M
3.
plus
2.
3. Now, you know what 2M is. It's only one number adds the 3 to give 27. What is that number, Audrey?
24.
24. So that means we know 2M is 24. So M is what?
12.
That's it. That's it. Mental math. You got it. That's it. Yeah. I mean, you could subtract the 3, both sides get 24 and divide by 2. But just looking at this 27, only one number adds to 3 to get 27. That's 24. So that means that 2M must be equal to 24. So M equals 12. So 12 is the number of miles. All right. Questions? Okay, let's go to the next one. Next one is a series of graphs. The gas tank in a car holds a total of 16 gallons of gas. The car travels 75 miles on 4 gallons of gas. The gas tank is full at the beginning of the trip, which means it has 16 gallons at the beginning. Now, which graph represents the rate of change in the amount of gas in the tank? Now, there's 4 different graphs. There's one that's here. That's one of the graphs, right? And you're starting out at 16. Well, this one is starting out at 16, but you've got to find out if it satisfies the rate of change, right? 75 miles on 4 gallons. So if you use 4 gallons, you're going from 16 to 12, right? So in this first one, 16 to 12, how many miles did you go? You read it off right here. How many?
8.
No, what's your number of miles right here?
Oh, that's 30.
That's 30. So it says 75 miles on 4 gallons. But if you went from 16 to 12, that's 4 gallons. That's not 75 miles. That's only 30. So it can't be number 2, right? Questions? How we eliminated number 2? See, it said the car travels 75 miles on 4 gallons of gas. $75 miles on 4 gallons. We started out with 16. So if you use up 4 gallons, you at 12, right? But at
Mhm.
12, see, 12 is over here on the Y. But at 12 gallons, we only went 30 miles, not 75. So it can't be A. Any questions on why it can't be A? All right. Now let's go to the next one, B. Now, B, it can't be B because we started with what? 16. And here you started with 0. See, over here is the gallons. Right here, that's 0 gallons, right? And 120 miles. So it can't be B because we started with how many gallons?
16.
16. So we should be here, right? So it can't be B because B started with 0 gallons. Because on this graph, you at this point 120 miles, and you go over here on the 0 on the Y line, and that's not where we started. Okay, not a 16. What about C? Where did we start? How many gallons at C?
16.
16, right? Now, when we go to 12, 12 would be the 4 gallons, and that should be at 75, right? So 12 would be right here. And 60, it's like midway between 60 and 90, that's 75 gallons. So that would be the correct one, right? And if we go 4 more from 12 to what, 8, there we go, 150. That's another 75. So that satisfies our 75 miles per 4 gallons. So the answer is C. Question? Answer C. Okay. And of course, the last one, you're starting again at 0, not at the 16. So it can't be this one. You have to pick out the ones that started at 16. There was only 2 that started at 16, A and C. But A didn't travel 75 miles. So that's how we eliminated that one. So it can only be this one. Any questions? Okay. That's why you have to read these word problems carefully. And the important thing here, and that's why I underlined it. Okay. The car travels 75 miles on 4 gallons of gas. That means when you read off the gallons on the Y and the miles on the X, you should see 75 miles on 4 gallons. So 16 to 12 is 4 gallons, but your miles is not 75, it's 30. So you could really stop here and say, let me go to the one that started at 16. So it's the only one other one started with 16, and that's the one that has C. Okay, right here. Questions? Okay, let's go to a new share. was, all right. This still functions. Okay, here's the word problem. Callie makes sandals at home. The sandals making tools costs $100 and he spends $10 on materials for each sandal. He sells each sandal for $30. How many sandals does he have to sell to break even? Now, to break even, you have to have cost equal revenue. All right. So you're gonna write your function for your cost and write your function for your revenue. So what makes up your cost, Latoya? What components here make up your cost?
What you said?
$100.
Okay.
Yeah, and what else?
And the $10 for the material?
That's right.
Yeah.
That's what makes up your cost right here. $10 for the tools and $10 on materials for each sandal. That's what make up your cost. Now, what does your revenue come from, Audrey?
From what you sell?
That's right. And what do you sell the sandals for?
$30.
Yeah, there's your revenue right there. That's your revenue. So we know our cost is the tool cost at $100. That's a fixed cost. $10 for each sandal sold. So your cost revenue, your cost, and we're saying S, we're letting S variable be the number of sandals. So the cost of the sandals sold is $10 per sandal. I mean, 10 to make the sandals, $10 for the material plus $100 for the tools. Now the revenue is just 30, that's what you're selling them for, times the number of sandals sold. So to break even, your cost has to be equal to revenue. So what you do is you take these two functions and set them equal to each other. 10 plus 100, 10s plus 100 equal 30s, and then solve for s. 10s plus 100, subtract 10 from both sides, you get 20. 20s is 100. 100 divided by 20 is 5. So you must sell 5 sandals to break even. All right. Now, Chastity, how many sandals would you have to sell to make a profit? Chastity, you're on mute. Chastity? You're
Sorry,
on
Miss
mute.
Barbara.
Yes, how many sandals would you have to sell to make a profit? If 5 sandals, you break even. In other words, revenue is equal to cost. So how many sandals would you have to sell to make a profit?
I can't solve it. There's no way you can. See? Yeah, that's correct. Well done. The extra credit points for the next test. Dang, this wasn't fair. I don't know how we're gonna
5.
teach that special needs.
Well,
Dang.
5, you break even. You don't make a profit. Your revenue and your cost is equal. But if you want to make a profit, that means your revenue has to be greater than your cost. So what's the least amount of sandals you can sell and make a profit?
10.
No,
21.
25.
no, the least
The least.
least number of sandals you can sell and make a profit.
Okay. Go away.
2.
What?
4.
No, it's, well, if 5 breaks
That's why
even,
we break it even.
then you've got to sell more than
Uh,
5 to make a profit, right?
Right, yeah,
So the least
Okay.
number would be
6?
6. Yeah, 6.
6, oh, okay.
6 sandals, you'll make a profit. That's the least number you can sell to make a profit. Because if 5 breaks even, you sell 1 more sandal and
Right.
you'll make a profit.
Something.
Because what you'd have 6 times 30 is 180. And 10 times 6 is 60 plus 100 would be 160. So your revenue would be 180, your cost would be 160, and you make a profit of $20. Got it? That's why I said the least. So anything greater than 5 will be a profit. It's just that the least number of sandals you sell to make a profit is 1 more than 5, which is 6.
So if you multiply the 6 by the 30, you get 180.
Right? And then you
And then
take
you,
that
and then you
same
multiply the
6.
same, huh?
Yeah, go ahead, Audrey.
No, and then it was saying if you multiply the 6 by 10 and get 60 and you subtract it from the 180.
Kyle.
Yes.
what
10
did you-
times 6 is 60 plus 100 at 160. 6 times 30, 180. 160 from 180 give you a $20 profit.
Right, right.
Yes, that's right.
Okay.
Very good. But see, we had to put our functions here for cost and for revenue. And we got that from the words here.
Mhm.
Tools was 100.
What?
$10 for material for each sandal. So that's how we got our cost function. $10 per sandal plus $100 for the sandal making tools. The revenue, what we make for selling the sandals, is $30 times the cost of the
Not any
sandals.
well, thing you do.
Questions?
You talk- Of course he is. You'll see. Starting today,
Where's the noise coming from?
brilliant in every activity.
Where's the noise?
I think somebody talking.
Yeah, I know. That was from,
It sounds like a little baby or
that was
something.
Chastity, I think. Okay.
Oh,
All right, let's look at number 2. You work 40 hours a week at a furniture store. You receive $220 weekly salary plus a 3% commission on sales over 5,000. Okay, assume you sell enough this week to get the commission. So you have functions. Now, we call these composite functions, and we'll get more into them later about what they are, but I just want you to see it from a real world example. So we have f of x is 0.03 times x, where x represents the number of sales over 5,000, right? The g of x is x minus 5,000, which is the amount over 5,000 that you get commission on. So which of these represents commission? You could say f of g of x or g of f of x. Now, when we say f of g of x, that means that function g of x is input to the f function. When we said f of x, g of f of x, the f of x is input to the g function. So which one do you think we have to do first? Just look at it. Which one do you think we would do first? The g of x or the f of x?
F of X.
F of x? Now remember, it said you get 3% commission over 1,000.
Oh, 2%. 2%.
Over 1,000. So that means you've got to find how
G
much did
G
you
of X.
exceed 1,000, right? So that g of x has got to be done first,
Yes, yes.
right? because you've got to find, what do I apply this 3% to? It's whatever excess over 5,000. So then you have to do this one first. That's why your answer would be f of g of x, because g of x would be the input to the f of x. All right. See, notice here the example. The g of x is x minus 5,000. So if your sales were 6,000, you subtract the 5,000 from the 6,000, you got 1,000. That's what you apply the 3% to. So the FG of x would be 0.03. That's the percent commission on the excess over 1,000. So 0.3 over 1,000 gives you $30. That would be how much you would make in commission. Questions? See, the other way around would give you negative numbers, and you certainly wouldn't want negative numbers. Now, we'll get back to some composite functions. Okay, so what you do something.
0.03.
Now,
0.03.
Latoya, read this problem.
100.
Latoya, you're on mute.
Let's see what that's.
Latoya, you're on mute.
Yeah, I see that.
Read number 3.
Where it is that? Jimmy is having a birthday party at the zoo. The zoo have a fixed fee of birthday parties plus a fee per person. Jimmy is told that the total change for 10 people. Charge, shucks, including himself, will be $97.50.
Oh, God.
The total charge for 20 people, including himself, will be $175. Determine the
2 function statements.
the 2 function statements.
Independent, dependent variable, and the initial value. So let's determine the function statements. What would be the 2 function statements?
SX.
Where's SX?
You hear me, Miss Barbara?
Yeah, I hear you. Okay.
Oh, you're not answering, so I don't know what I'm saying.
All right. Let me give you some variables here. The fee per person will be
I
equal
think you're
to
hearing me.
X. The fee per person is X. We have a fixed fee. We'll call F. Right? So I'm
Yeah,
giving
that's
you
what I said, F of X.
okay. No, I'm giving you the variables.
Oh,
Okay, you're right, F of X. So fee per person is X. The fixed fee is F. All right, because it said there's a fixed fee. They gave you this, right? So that means we've got to define this as a variable, and then we have a fee per person. Right? Now, tell me what to write, Latoya. What would be the one of the function statements?
97. Let me see.
Okay.
97 plus 120, 75.
Okay, you
97.
tell me the function for that one.
You're gonna be 10
It would be
and
what?
97. Oh, I'd put it. I'm like lost. You're gonna say the 10 is gonna be in the F. the F section. And then it's gonna be 97.50.
What do you
Then
have?
750. Oh, okay. Plus the 20. You understand? It's cool.
No, I want the function.
Oh, it's FX. FX. Oops.
Okay. T
Yeah.
is total for
I thought you was working it out. That's why.
the party. Now, I'm giving you the variables. So,
Oh,
so now you're going to tell me what to write for the when it's 10 people.
that's
What would
what I
I write?
think you was at. That's why I was saying that.
Okay, tell me what to write.
I said, it's gonna be. Total charge for 20 people.
For 10 people, what would this be?
It's in the F.
9750.
What's the total equal to? T,
9750.
we'll say T, well, that's the total, right? But that's the total for what? How many people? 10.
For 10 people, yeah.
And what is that equal to?
97.50.
No, in terms of a function. What makes up that total?
So it's gonna be equal to 9750x.
No. What makes up that total is a fixed fee and a fee per person. So a fee per person, how many people are there? 10,
10.
right?
Yeah,
And the
plus
fee per-
97.
That's no 10x.
X, yeah.
10 people times the fee per person, X, plus what?
97.50.
No, plus a fixed fee of F.
I don't understand this one.
No, the total for 10 people would be 10, that's the number of people, times X, the fee per person, plus the fixed fee. You follow? Now we know what this T of 10 is. They gave us that 9750. And we can substitute that in, right? But the total for these 10 people is 10, the number of people, times X, the fee per person, plus F, the fixed fee. And we can do the same for the 20, right? So what would that be? What would T of 20 be, Latoya? What would that be equal to? How many people? Latoya, you're on mute.
9750.
No. How many people are there? Well, you know
200.
that from here. 20.
20
20.
people.
So 20 times the
20.
that's
X.
right, times X.
20 times X.
And
Plus
yeah, plus
175.
no,
Plus F.
Oh,
plus F.
Plus F.
why is it gotta be extra? Oh,
Because it's
God.
Because remember I said the total is
Total is
equal
fixed.
to the cost per person times the number of people plus a fixed cost. See, it said it has a fixed fee plus a fee per person. So my F is my fixed fee and my X is my fee per person. That must be multiplied by the number of people.
Mm,
You follow?
no. I don't understand this.
It
No,
says
no.
the total cost.
The function, the total cost is the sum of what? The fixed fee plus the total fee for all the people using the fee per person. But we don't know what that is. That's what we're going to be solving for, right? But they gave you the total. What's the total for 10?
97.
$97.
That's right, 97.50. So we can put here 97.50 equal 10x plus f. And then the next one for 20, what did we pay? What was the total?
175.
That's it, 175. So we can put 175. Okay, that's in dollars, equal 20x plus
That's F.
f, right? So I have two equations and two unknowns. Does anybody know how you solve equations? These are simultaneous equations, right? How would you solve this equation? Two unknowns. You have two ways you could do it. You could do one called substitution, one called elimination. In other words, how can we eliminate one of these variables?
Is subtracting?
You could, but what do you have to do before that, Audrey? Because there's nothing in common here, right? But if we multiply, yeah, that's right. Multiply this equation by 2. And why are we multiplying by 2? Why do you think we're multiplying by 2?
Try to even it out.
No, because then I'll get
Because of your
20.
mark of people,
I get
you have 20
20x,
people.
and then I can subtract. And if 20x minus 20x is 0, so I can eliminate my x, right? That's why I'm multiplying this whole equation by 2. Okay, because I want to eliminate one of my variables, so I can just solve for one variable. Then I can use that to solve for the other variable. Okay, so what's 2? So this equation, okay, this is equation 1. This is equation 2. All right. Now, equation 1, what's 2 times 97.50? When I multiply this whole equation by 2, what do I get?
$195.
Okay, 195 equal what? 2 times 10x, Audrey? 2 times 10x. Remember, I'm multiplying 2 by this whole equation. What's 2 times 10x?
20x.
20x, that's right. And what's 2 times f?
2 times F is 2F.
That's it, 2f. Okay, now we can subtract 2 from this equation. Okay, subtract number 2 here from this equation. So I can take this equation now and subtract it, and I'll just have one unknown. Okay. Okay, subtract this. Let's put this here. Draw my line. And you're subtracting. Okay. So what's 2? What's 175 subtracted from 195, Audrey?
It's 20,000. 20.
Well, just 20, right? So
Mhm.
20, so that would be 20. And 20x minus 20x is what?
It's 400x.
No, 20x minus 20x.
Or 20x minus 20.
Is
It's
it
X.
0? No, 20x minus 20x
400x.
is 0,
Or
right?
20x.
20x minus 20x is 0.
Oh my, I thought you said times. I said times. Oh man.
No, it's
That's- it's zero.
subtracting. I'm subtracting. That's
Subtracting, yes.
0. And what's 2f minus f?
2f
2f
minus
minus
3f.
1f.
It's 2.
What is it?
2.
3F.
No,
1f.
1f. That's it.
Oh, subtract. Sorry.
1f. 2. This is the coefficient of 1, right? That's your default.
Okay,
So this is
minus.
okay.
Yeah, wait a minute. She got
2f minus 1f. So this would be plus
with
1f, which is the same as f. So f then, that means f is equal to what? F equals 20. F was our fixed fee. That's right. So that means that our initial value is $20.
one. That is 2. Okay.
Okay, so we have our initial value of $20. That's what our F was, 20, right here.
98.
All right, now we know what F is. Now we can take any of these equations here and solve for X, right?
Mhm.
We can take this equation. We know what F is, we can solve for X. So let's just take this equation. Okay, put it here. So we're use equation
Excuse.
to solve for
Where she is now.
X.
Perhaps
So-
Barbara is-
So let's just take
Yeah.
this equation. What was F equal to?
Okay, where's she at? Let's say she on.
F was 20, right?
Yeah.
So we put out 20, substitute the 20 in here for the F. Okay,
Let's say that you're on, Miss Barbara, and not seeing you.
and I'm on the other side.
It's Barbara.
Yes.
Oh, okay.
Yeah, my phone is dying.
Where's your charger?
I'm just reaching home. My phone is practically dead.
175. 100.
I didn't charge it last night.
Oh, you gotta charge it.
20.
When you have a lot of things to do, trust me. I have to make my son put on back there to see if it is, what you call it?
So, 75.
Saving battery.
How do I solve this for X?
X.
175 equal 20X plus 20. Audrey, how do I solve this for X?
Okay. Sure.
What do you do first here? You want to solve for X.
Yeah. You
Well,
subtract the 20 from both.
That's right. Very good. Subtract 20. Subtract 20 from both sides. All right. Now that would, let's just do that. Take this and subtract the 20 from both sides. So that would be 175 minus 20. Let's go there. And this is minus 20. So Audrey, what's 175 minus 20?
155.
That's right, 155. And that would 20 minus 20 is 0, so that would just be 20x on the right side. Right? So that would be equal to 20x. Now, Audrey, how do I solve for x? Add
Okay,
both sides by what?
20.
I said, very good. By 20. So we'd have x equal 155 divided by 20. And that gives you $7.75. So that would be the rate of change, $7.75. That's what each person would pay. Okay, in addition to the fixed fee of 20. So
Okay.
that would be $7.75. $7.75. Okay, so we have $7.75 per person plus a $20 fixed fee. All right. Now, what is the independent variable, Audrey? What is the independent variable? Or what is the dependent variable? What is the dependent variable?
The variable, dependent variable.
The dependent variable is what? Is it T? Is it F? Is it X? Which one?
Is F.
No.
And the
Dependent variable is the total,
Oh, yeah.
right? It's the total for the party. That's our T of N. That's we calculate by knowing what? How many people
How
and the
many
cost
people?
per person. So
Mm.
what's the independent variable?
T of N. Okay.
That's the dependent variable. What is that dependent upon?
The variable,
The dependent variable is dependent upon what?
independent variable.
Yeah, what is the independent variable?
Yeah, sure.
The independent variable is the number of people,
Oh,
right? Because the more people, the more you're going to pay, right? Number
okay.
of people. So you have a fixed cost, and then you have a cost depending upon the number of people. And that $7.75 you pay for each person. So your dependent variable is the total. That's this. So if you have T of 10, so if you had 10 people, you're going to pay 10 times the cost for one person, which is at $7.75, plus the $20 initial fee. That's the fixed fee. Okay, so the dependent variable is the total for the party, right? And the independent variable is the number of people. The dependent variable depends, that total depends upon the number of people
People.
that you
And
have for the
independent
party.
what? And
The independent
dependent-
variable is the number of people. Dependent variable is the total that you spend for the party.
the total of people.
And what
And
changes
independent-
that? The $20 is a fixed cost. So what is varying? The number of people. The more people you have at the party, the bigger your total. So your dependent variable is the total for the party. The independent variable is the number of people. The initial
Okay.
value is that fixed fee of $20, and the rate of change, which is the slope, that's the $7.75 that you pay per person.
Mhm.
Okay, that's the fee per person. So that's your X, the $775. Your fixed fee is the $20, and your total is what you pay for the fixed fee plus 775 times the number of people.
Hmm.
And these are your two function statements. T of 10, 10x plus F. T of 20 is 20x plus F. But you were given these totals, so we can substitute these in and do an elimination where we can eliminate one of the variables and solve for the second one, that's the F, and then we can use that F to solve for our X. Any questions?
No, it's a long job though. It's a lot to do.
Yeah, it's a lot to do, right? Because it's really 4 parts to it.
Okay.
First, your function statements, and then your function statements have 2 unknowns. So to get the unknowns, then you have to use the methods to solve for the unknowns. And like I said, we use the elimination method, which I think is easier. You could use the substitution where you can write one equation in terms of the other and then substitute it. But I think the elimination method is better and probably easier. Okay. So that's called the elimination
Okay.
method for solving simultaneous equations. And all simultaneous equations are equations that have more than one unknown. We some of them gonna have like 3, 4, but we'll only be doing 2. And simultaneous equations have 2 or more unknowns. Here we had 2 unknowns, and we try to get it where we can eliminate one. And when you look at something like this, you say, well, what can I do that make one variable number equal to the other one? Then I can do a subtraction and then just end up with 1. So I used this one times 2 because I know this 20x, and I have a 20x here, and then I can subtract and eliminate the x and solve for the f. And then once I get the f, I can take either of these equations to solve for the x.
Okay.
All right. Questions?
No.
Now, I said I would say something else about, okay, composite functions. A composite function is a function that depends on another function. Now, we briefly looked at it when we looked at the commission problem. Okay, so what this looks like is you could have 2 functions like f of x and g of x. G of x function could be the input to the f of x. We call that a composite function, and we write it as f of g of x. All right. The inner function is the g of x. The outer function is the f of x. That means you have to solve for the inner function first, and then you solve for the outer function. All right. Now, just to give you an example. Okay. Emily visited an amusement park with her family, and the cost of the entry tickets was different for people of different ages. The 3 different categories of age groups. Latoya, is that you? Go to mute. Latoya?
You always rush me to take a picture and you're never ready with that.
Latoya, go to mute.
Take a picture.
Latoya, Latoya.
I would have never noticed that. I never noticed that. I just take pictures.
Latoya.
Sometimes you take
Latoya, go to mute. Latoya, we hear the conversation. Mute yourself. Latoya, Latoya.
I don't think she can hear you.
I don't think so, but she's somebody talking to her. I think she may be in the cab. Latoya,
Wipes, the bleacher, whatever wipes.
Latoya, go to mute.
Which one though?
But you
Latoya.
can mute her too, Miss Barbara. You can mute her too.
See if I
So
can.
good.
I don't think I can. I'm not the administrator.
That's amazing.
Miss Beckles can mute her, but I can't.
Oh,
Latoya. Latoya.
That's like what?
Latoya, go to mute. I have to tell her when she's getting a cab, just go to mute because it's too disturbing, you know. Okay, the three different categories of age groups were kids, adults, and senior citizens. How can you relate the given information to composite functions? So the cost of the tickets, we can say f of y. Another function could be the age group of the person, g of x. Now, the cost of the ticket is dependent on the age group of the person.
Well, all we have is blueberries. That's it. What is that?
Latoya. Latoya. Okay. The cost of a ticket is dependent on the age group of the person. So we can say y equal g of x, where that's the age group. So the composite function to represent the cost of the ticket can be f of g of x. In other words, the f of function cost is dependent upon the age group, which is g of x. So g of x is the innermost function, and f of x, the cost of the ticket, is the outer function. That's what we mean by composite function. A function is the input for another function. Okay, now this becomes a little clearer when you see some examples of it. Okay. In fact, I gave you some steps to use to solve it. Okay, so if you have, first you write the function f of g of x. That g of x is here the input. The f of x is the output. That's the outside function. So what you will be doing is the x in the f function, you'll be replacing with what's in the g of x function. Okay, example. F of x is minus 2x plus 7. G of x is x minus 9. Now, if you're finding f of g of x, you're going to do the innermost function first, which is g of x. So g of x is x minus 9. That means we take this x minus 9 and substitute it into our f of x right here. So where we have x, we put what the g of x is. So that function is really input to the other function. So once we put that x minus 9, we substitute that into this function. That becomes minus 2 times x minus 9 plus 7 and minus 2x plus 18 and 7. And your answer is minus 2x plus 25. Any questions of that example? A function is input to another function. And the outermost function, that's the one you see here, f of x. The
So you take the
innermost,
fx,
go ahead.
you take the fx, which is equals to 2x plus 7, and put it into the gx. That's what
No.
you're saying?
No, I take the minus 2x plus 7. That's my f of x, right? Now my
Uh-huh.
input to this function is my g of x. So I
Right.
take my x minus 9, and wherever you see a x, I put my x minus 9. That's why I have it here. Minus 2
Right.
times x minus
Mhm.
9 plus 7.
FG.
So it's a function input to a
Mhm.
function. Now we've been using just expressions for inputs, right? But now for composite function, we have two functions where one is input, one is output. The innermost one, when we express it, like here, f of g of x, that means g of x is my input. What is g of x? X minus 9. I take that x minus 9 and substitute it in for x in my f of x function. See, notice I have the x minus 9 for the x. Then I just do the math and get minus, this is minus 2x. Minus 2 times minus 9 is a plus 18, plus 7 be 25. Is it making sense?
Yeah. Okay, so the minus 2x or the negative 2x times the 9 and then add 7.
Well, no, it's times the x minus 9, Audrey. See, the g of x is the input. So I take this x minus 9 and substitute it in for the x. So 2x becomes 2 times x minus 9.
So 2
And
times
that's
the
a
x would
minus.
be 18, right? What that would be 18 plus the 7?
Well, minus 2 times a minus 9 is a 18. And 18
Right.
plus 7 is 25.
Plus 7, right. Mhm.
That's right. And then a
Mhm.
minus 2 times x is a minus 2x. So you
Mhm.
substituting the function for g of x into the function f of x.
F of x,
So
okay.
where you see a variable, just put that other function. So instead of x, I put x minus 9, which is what I have here. 2 times x minus 9, and then do the math, and you get f of g of x is 2x plus 25. So a composite function is really a function of a function, where one function is input, the other function is output.
Okay,
Got it?
I think so.
Okay. Well, I have another one here. Okay. Let's take this one. Take one more example. Okay, here we have it here. You see this example? F of x is 4x squared plus 3. G of x is equal to 2x plus 1. All right. Now, sometimes you'll see this with a dot, like F. Well, it's sort of like a multiplication symbol, but it still means F of G of x. So G of x is my input. So I take my output, my F of x, which is 4x squared plus 3. And x is 2x plus 1. That's my input. So I put my 2x plus 1, and that's squared because x is squared. You see it? Plus
Which side
3.
you on?
I'm on the right side.
On the right side, which is my left side.
Mhm.
I ain't seen it yet. Up or down?
You don't see this example?
Not yet.
Example, f of x equal 4x
Okay.
squared plus 3. G of x equal 2x plus
Yes,
1.
yes, I see that now,
Okay.
yes.
All right.
Uh-huh.
Now, when I say f of g of x, what is that equal to? That means my g of x is my input. So whatever's in g of x, I want to put it in my x right here, right? So 2x plus 1 will be 2x plus 1 squared because x is squared, right?
Mhm.
Got it? So 2x plus 1 squared is 4x squared plus 4x plus 1. That's all multiplied by 4. So you multiply that out, you get 16x squared plus 16x plus 4 and 3 will give you 7. So f of g of x is 16x squared plus 16x plus 7. You follow that? F of g of x. G of x is the
That's a little
input.
fast.
G of x is the input. That means this 2x plus 1 right here is substituted in for x in my f function. That's why I have 2x plus 1 squared. You following? All right. Then square the 2x plus 1. All right. That gives you 4x squared plus 4x plus 1. That's times the 4. All right. 16x squared plus 16x plus 7. That's the 4 plus 3 is 7. Latoya, go to mute.
We do something wrong.
You have a problem? You have a problem?
Oh, yes. I think it come back on. You can hear me?
Yes, I can hear you. So
Okay.
Audrey, are you following?
Yes.
The input is what?
The input is
Is the
the
g of x.
g of x.
Yeah,
And
that's
that's
the
equal to
input.
4.
That's g of x is 2x plus 1, right? That means my input, 2x plus 1, I want to substitute it here for my x and my f of x. So that's why I have 2x plus 1 squared, because x squared would be input g of x, 2x plus 1 squared. And when I square that, I get 4x squared plus 4x plus 1. And I had this 4 in the front. And then just multiply that by 4 times 4x squared is 16x. 4 times 4x is 16x. 4 times 1 is 4 plus 3 is 7. That's how we got f of g of x is 16x squared plus 16x plus 7.
Plus 7.
You following?
Yeah.
Now, what about if it's g of f of x? What's the input, Audrey? G of f of x.
G of x. It was G.
What's the input function?
It was G of x.
Yeah. G of f of x. What's the input? Input now is f of x, right?
F of x. Yeah.
F of x is what? 4x squared plus 3, right? So now I take that f of x, which is 4x squared plus 3, and put it in my g of x. So that's why I have 2 times 4x squared plus 3. You follow?
Yeah.
My f of x is now my input, right? And my input is 4x squared plus 3. And I substitute that into my output, my g of x. 2 times x is 2 times 4x squared plus 3. That gives me 8x squared plus 6 plus 1, 8x squared plus 7. Questions? Any questions on composite functions?
Okay.
Just remember in this format, G, where you have G of f of x, the f of x is your input, the G of x is your output. Up here, f of g of x is your input, f of x is your output. All right. That means you take the g of x, 2x plus 1, substitute it into the x of your f of x. All right, because that's the input. Down here, g of f of x is my input. There's my input, 4x squared plus 3.
So that means you switch then? That's what you switch it.
Yeah, I switched it, right?
You switched
Because
it.
here, G of X is, that's right, Audrey, exactly. G of X is my input. In this
Right.
example, F of X is my input. So I
Right.
take my F of X and I put it into my
Into the
G of
of
X, which
X.
is my
Okay.
output. Okay,
Okay.
so they're not the same now, because if
Mhm.
I say G of F of X is my input. If I say F of G of X, G of X is my input.
Okay.
Questions?
Okay.
All right, we're gonna stop here, and I have some homework for you to do on composite functions. I think, let's see, I have one, let's see, 1, 2. Okay. So this is what I'm giving you, and I want to know if you can find the mistake the person made. Okay. So this is and it's just really one problem. No, I'm sorry. It's 3 problems. First one, I gave you information, ask you, the person did the work, made a mistake. I want you to find what is the mistake. And then the other one, G of F of -2. And here's your F of A and your G of A. That means the -2 is going to be your A, right? And this one, F of N square root, this 10N is square root of the 10N. G of N is N squared minus 10. G of 10 is your input. F is your output, right? This one, the F of -2 is your input and the G is your output. All right, so you have 3 homework problems to do.
G of F. Okay. G of F is the output. G of F is the input.
Well, for this one, G is the output. F of -2 is input. F of G of 10, G of 10 is your
Yeah.
input and F is your output.
All right, let me write that. G of N, you said?
Is your input. That means, Audrey, this says G of 10, right? That means you've got to put that 10 wherever you see an N.
Okay.
And then once you find that, then you're going to substitute that value into your F of N. So first calculate your G of 10. That would be 10 squared minus 10, right?
Mm-hmm.
And then use that in your F of N. So that value you get, you put it in there for N and then get the square root. You got it?
Okay.
The same thing for this one, F of -2. So you're going to put your -2 wherever you see an A. So that's going to be a -2 plus 2 squared. All right. And then once you get that, you're going to take that F of -2 value and put that in for your A here for G of A. Okay.
Okay.
Substitute the number, solve for the input function, then put that value in your output function. Okay. And if you want to try some of these and send me some answers, it's okay. And I'll check them for you and send back what you should do on them. Okay.
Okay.
All right. So that's
All right.
3 problems homework on composite function. And we'll continue. I think I have some others here. That's practice, but those we'll do next time. But if you wanted to try some, it's okay. All right.
Okay.
Any questions?
Oh, not right now. Halfway there.
Okay. So,
Try it.
all right. So we're going to stop here.
Okay.
Let's see.